I realized when I was getting ready to make the video for section 2.3 that I had failed in our extra example of a stem and leaf plot, or specifically in this case a back-to-back stem and leaf plot, that I had failed to make my legend. So I'm going back to do that now. Legend. So let's just say, for example, 4-line, it's really not correct. Let's say 2-line, 4-line, 3 means 42 for an actor and 43 for an actress. Okay, now that we've corrected that mistake, let's move on to section 2.3. So we're going to talk about stem and leaf plots a little bit more. And then we're going to discuss cumulative frequency and cumulative relative frequency distributions. So, if you recall that one advantage of the stem and leaf plot over frequency distributions and histograms is that the raw data can be retrieved from the stem and leaf plot. So in a stem and leaf plot, we can determine the maximum and the minimum observations. It's not possible for us to learn that information from a histogram. On the other hand, remember, stem and leaf plots lose their usefulness when the data sets are large or consist of a very large range of data. So remember, here's another stem and leaf plot. And this time they want us to determine the original data set and describe the shape of the distribution. So our legend says that 7 for the stem and 1 for the leaf represents 7.1. So if we need to make our data set, we can just list it out. So we have, from the first line, we have 7.1, then 7.3, another 7.3, 7.4, 7.5, 7.8, and 7.9. Sorry about that little Zoom pop-up screen that showed up. Okay, you should pause the video and try to recreate all the rest of the data values and then restart the video and see if you're correct. So, for those of you who did that, we should then have 8.4. Sorry about the Zoom pop-up again. 8.5, 8.5, 8.6. Then keep going. 9.2, 9.4, another 9.4, 10.1, 10.6, 11.1, and 12.4. So we've now recreated the data set. How do we determine the shape of the distribution? Well, if you recall, we said that in the last section that a stem and leaf plot kind of looks like a histogram on its side. So if we were to rotate this 90 degrees to the left, we would have something that looks approximately like this. And so this is like 7 to 8 to 9. Let's see, 10 is smaller. 9 to 10 is smaller. Then 10 to 11 and 11 to 12. So this is what it would look like. And the highest point is at the left. And then it keeps getting shorter. So remember, this part is the tail. And when the tail is longer to the right, we say the data is skewed right. Or right skewed, hyphenated, whichever. It's the same thing. Okay, so a little bit more about stem and leaf plots. They can also be used to compare the two data sets. And we did that in the extra practice problem I did in the last video that I corrected at the beginning of this video. And so we can do that with that back-to-back stem and leaf plot. And both plots are made using the same stem, and the leaves for one data set go to the left, and the leaves for the other set go to the right. So here's another example of these. We have, let's see, it looks like our stems are going to be 5, 6, 7, 8, 9. And remember, it's easiest if you put them in ascending order, the original data to start with. So you should try to do this back-to-back one on your own, and then you can start the video again and see if you get it right. So I'm just going to fill these in because I've already done it. So for leaves, for the women, for 5, we have 1 and 3. For the men, we have 8 and 9. 6, we have 5 on the women's side. I'm just going to go fill in all the numbers here. Then 1 and 6. And for 9, we have 4, 4, 7. We have 1, 2, 8, 3, 4, 6. 1, 1, 8, and 2. Now let's not forget our legend this time. So legend. So I'm going to do 1, 6, 5 equals 6.1 for men and 6.5 for women. Okay, I think we'll stop this video here. I lied. We'll keep going for a minute. We can finish this up real fast. So when the data is really bunched together in a stem and leaf plot, it can be necessary to split the stems. And to do that, we use 2 stems for every class. And we put 0 through 4 leaves on one stem, the first one, and we put the 5 through 9 leaves on the second stem. So let's split the stems. And the reason we're doing that is because it seems pretty bunched up. So to split the stems, we're going to have 2 7s, 2 8s, and 2 9s. And I need to make this smaller or it's not going to happen. So 7, 7, 8, 8, 9, 9. So on the first 7, we're going to put all of its leaves that are 1 through 4. Sorry, 0 through 4. So that's 1, 2, 2. On the second one, we're going to do all the leaves that are 5 through 9. So that's 5, 7, 8, and 9. The same thing for 8. 0 through 4s go on the first 8. So 0, 1, 3, 3, 4, 4. And the 6 and the 7 go on the second 8 because that's the stem for the 5 through 9 leaves. So for 9, we put 1 and 3 on the first 9 stem and 6 on the second 9 stem. And the legend still works, so we don't need to make another one. So that is it for this part of the 2.3 video. We will talk about cumulative and relative frequency distributions. Sorry, cumulative frequency and cumulative relative frequency in the next video.